Well, welcome back to our class on system design as we explore system analysis and design with the textbook that we're using here, Dennis, Wixom, and Roth, primarily focusing on information systems. This is related to our system engineering course that we have, and also because we're focusing on an information system, it also has some relevance to the software engineering course that I also have recorded. So you may want to keep that in mind and look at those as well. So this is the second of 4 lectures where we're dealing with the second phase, the analysis phase. We went through the requirements determination. That was the primary focus of how we elicit those for an information system in chapter 3. And now that we're going through chapter 4, we're going to be thinking about use case diagrams and process models. And so this will be the primary focus that we want to get some greater sense of what it is. And so there's a lot of graphical material in this. I'll try and walk through the majority of it, but I also would refer you to the textbook to get some additional insight. So information systems support people who use the system to perform activities and tasks. Use cases and process models are used to help understand and describe the tasks the system must support. That is, functional requirements and how those tasks must be organized into processes that complete the response to an event. Use cases are used to explain and document the interaction that is required between the user and the system to accomplish the user's tasks. Use cases are created to help the development team understand the steps that are involved in accomplishing the user's goals more fully. Once created, use cases often are the basis for detailed new system functional requirements. Process models graphically describe business processes, the activities that people do. And so here are the objectives that we hope to pass on as we're going through the material in this chapter. We want to explain the purpose of use cases in the analysis phase of the system development life cycle, the second of 4 phases that we're covering. Describe the various parts of a use case and the purpose of each part. Describe how to use these use case to contribute to the functional requirements. We'll describe how use case information informs the development of test plans. We'll explain the processes used to create a use case. We'll explore the rules and style guides for data flow diagrams. We'll describe the process used to create data flow diagrams, and we'll also explore creating data flow diagrams. So hopefully you'll get a chance to get one perspective of how we can be doing use cases. There's other ways too. I do have some lectures that talk about the system modeling language, which is an alternative way of looking at use case diagrams. So a key aspect of determining the requirements for a new system is understanding the user requirements, the things the users needs to accomplish with the new system. Use cases help us understand and clarify the user's required interactions with the system and can help us more fully understand the functional requirements of the new system. A use case represents how a system interacts with its environment. Use cases are especially valuable for business system applications and websites. Process models have been a part of structured system analysis and design techniques for many years. So you can keep that in mind. So what is a use case? It's a depiction of a set of activities performed to produce some output result. Each use case describes how an event triggers actions performed by the system and the user. Everything in the system can be thought of as a response to some trigger event. And I'll just use a little bit more perspective from the text. And so a use case depicts a set of activities performed to produce some output result. Each use case describes how an event triggers actions performed by the system and the user. With this type of event-driven modeling, everything in the system can be thought of as in response to some trigger event. When there are no events, the system is at rest, patiently waiting for the next event to trigger it. When a trigger event occurs, the system and all the people using it respond, performing the actions defined in the use case and then returns to the waiting state. So here is some basic information that we have in a use case. And so it has a name, it has a number, and a brief description. It has a priority that can be assigned to indicate the relative significance of one use case versus another. The actor refers to the person, another system or hardware device that interacts with the system to achieve a goal. So the actor does X. The trigger for the use case is the event that causes the use case to begin. And event triggers can be either externally triggered or temporally triggered. Those are possible things that you can have. So we want to explore, create a preliminary custom drone order use case. And so this is the casual format. And once again, this is the drone tech company we're using as an example. And this is how we can be thinking what a casual format would be for this. And so when we have a use case, we have preconditions, what it does in a normal case, and post conditions. And so we'll see this over the next 3 charts. Preconditions, it is important to define clearly what needs to be accomplished before each use case begins. The preconditions define the state the system must be in before the use case commences. And so here are some sample preconditions. The customer is authenticated by logging into his account. Sales system order processing application is online. So with that, we can actually do what's in the normal course of activities for this use case. The normal course lists the steps that are performed when everything flows smoothly in the systems. And sometimes it's called the happy path. We'll get into, there could be other paths that we need to be thinking about. And here we have 10 steps. I won't read this, but basically it's ordering a customized drone is what we're trying to be doing with this use case and capture that. So once we have the things that it normally takes care of, we have the post conditions. So in this section of the use case, we define the final products of this use case. These post conditions also serve to define the preconditions for the next use case in the series. So you can be daisy chain use cases together with this kind of a construct. So post condition is unconfirmed order is stored. The confirmed order is stored, and the shop manager is sent notice of a confirmed order that requires approval. Well, what about exceptions? To be complete, a use case should describe any error conditions or exceptions that may occur as the use case steps are performed. These are not normal branches in decision logic, but are unusual occurrences or errors that could potentially be encountered and will lead to an unsuccessful result. We want to be sure that the system does not fail while in use because of an error. We can also be thinking about things in sequence. And so use cases are often performed in sequence. And so no single use case should be too large. It's important to define the initial and end states. And so here we can be seeing the various things that are taking place and acquiring a drone. So you have this precondition, normal, post condition, and it's going to the next one. So authenticate, place the order, tape approval, and transmit the order. So those are all the things that we've put together in a daisy chain of 4 different use cases laid out in that way. Here are some additional use case issues. Are there alternative paths from the normal that we need to quantify in some way? We want to make sure we have a summary of the input and outputs, make sure that we keep track of all that. We want to consider how often a use case is used. If it's used all the time, that's definitely going to be high priority. What about the business rules, the business rules that are contained in it? What about special requirements that we have to be thinking about? Assumptions, we want to make sure that's all clearly known and provided to everybody. And also we want to have the ability to have notes and a way of tracking issues. Okay, more elaborate use cases are especially valuable when, and here are some conditions, when the user representatives are not actively engaged with the development team throughout the project. The application is complex and has a high risk associated with system failures. The comprehensive test cases will be based on the user requirements. Collaborating remote teams need a detailed shared understanding of the user requirements. Here are some practical tips to consider for use cases. Use gradual refinement. And so maybe a top-down perspective system engineering, capture the top level functionality, and then you gradually add more detail as you go. You want to be concentrating on describing the user's objective with the system completely and accurately. You want to keep both audiences in mind, the users and developers. You want to create use cases only when needed to clarify what the system must do from the user's perspective. It's not needed for simple events. I have used use cases and how they specify it in SysML, the system modeling language, is they're meant to be kept simple and at a high level. So use cases and the functional requirements. Use cases are useful tools to clarify the user requirements. And so this can be something you can be working with a stakeholder. They can convey only the user's point of view, transforming the user view into the developer's view through functional requirements was one of the system analysts or the system engineer's key contributions. The derived functional requirements tell the developers more about what the system must do. So there's 4 steps for writing use cases. You want to identify the use cases, so have a listing of all that. You want to identify the major steps within each use case that you need to be capturing. You want to identify the elements within each step and then confirm the use cases. So in terms of creating, we identify events the system must respond to and develop event response list, create the use cases for the complex events. For each use case, you identify the major steps, identify the elements within each major steps, that's the input and outputs, included, and confirm the use cases with users through role playing. Finally, we want to be able to revise the functional requirements as needed. So what about the major steps? The analyst or system engineer should ask the users what tasks need to be completed before the use case steps can begin. Next, the user system interaction should be outlined as a series of steps in the normal course that when it's activated, the use case is activated. Each step should be about the same size as the others. Occasionally, a use case is so simple that further refinement is not needed. Once the steps have been outlined at the proper level of detail, the post conditions can be completed. So identifying the elements within the steps, the last column, the information for steps must be completed, and arrows may be drawn to describe inputs and outputs from the steps. The goal at this point is to identify the major inputs and outputs for each steps. The users and analysts and system engineers then return to the steps in the use case and begin tracing the flow of the steps. It's not unusual at this point for users to discover that they forgot to list the entire steps. The summary area for inputs and outputs found at the end of the use case form is completed once the team is satisfied with the steps, inflows, and outflows. Then we get into confirming the use case. The final step is for the users to confirm that the use case is correct as written. You want to review the use case with the users to make sure that each step and each input and output are correct. We can have data flow diagrams, and this is a technique that diagrams the business processes and the flow that pass among them. We use data flow diagrams to describe the 2B systems interactions with the environment, processes, flows of data, and data stores. Logical process models are models that describe processes without suggesting how they are conducted, and physical models provide information that is needed to ultimately build the system. That is covered in a later chapter, and so keep that in mind. Okay, here is an example data flow diagram for an event that we introduced earlier in the chapter, that of a shop manager approving a customer drone order. By examining the data flow diagram, an analyst or system engineer can understand the process by which the shop manager assesses the custom drone order. You can take a moment to examine the diagram before reading on. How much do you understand? Hopefully, as a result of going through this lecture, you'll get some better insight, but I also refer you to the textbook to also be thinking about it more. So most people from Western culture start reading diagrams from the left to right and top to bottom. So whenever possible, this is where most analysts try to make the data flow diagram begin. So that's what we see in this picture here, and you can see so this figure is the shop manager. We can see the shop manager external entity, which is a rectangle that represents the person and role responsibilities for approving custom drone orders. This symbol has 5 arrows pointing away from it to rounded rectangle symbols. The arrow represents the data flows and show that the external entities provide 5 bundles of data to processes that use the data. Also, there are several arrows arriving at the shop manager external entity from the rounded rectangles representing bundles of data that the processes produce to flow back to the shop manager. The use case for the approved customer drone order event would show these same inputs and output data bundles with the source and destination listed at the shop manager. So those are some things that you can be thinking about. And then in terms of syntax and the elements of the data flow diagram, now that we have had a chance to get a glimpse of data flow diagrams, we will present the language of the data flow diagrams, which include a set of symbols, naming conventions, and syntax rules. And so thus, and whatever kind of tool you're going to be using, having a certain type of syntax is always going to be something you'll have to explore. So there are 4 symbols in the data flow diagram language: processes, data flow, data stores, and external entities, each of which is represented by a different graphic symbol. There are 2 commonly used styles of symbols, one set developed by Chris Gain and Trish Sarson, and the other by Tom DeMarco and Ed Jordan. Neither is better than the other. Some organizations use the Gain and Sarson style of symbols, and others use the DeMarco and Jordan. For what we're going to be covering, we'll be using the Gain and Sarson. So this is the syntax that we'll be seeing as we move through this material, just to give you a perspective. Okay, let's have a handful of charts that start to get into the elements of data flow diagrams. And so first, for process and an activity or function performed by a specific business reason, can be a manual or computerized. It includes the following: a number, a name, which you want to have a verb phrase, as well, a descriptor, at least one output data flow, and at least one input data flow. Now for logical process, the logical process models omit any processes that simply move or route data and leave the data unchanged. You do include logical processes that perform computations, make decisions, sort, filter, or otherwise summarize data, organize data into useful information, trigger other processes, and use stored data. And you can see some examples in the parentheses. I'll just skip over that for time reasons. Now get into the data flow elements. A single piece of data or a logical collection of data is what it would be focused on. The data flow names describe the content of the data flows, but not how it is to be implemented. It always starts or ends at a process, and it includes the following: a name, so it's going to have a noun, a description, and one or more connections to the process. Next, we have data in motion, so an input of data to a process or other output of a data or information from a process, the creation, deletion, or update of data in a file or database. A data flow is depicted as a solid line with arrows, and control flows trigger processes such as time to run the weekly payroll. The control flow is depicted as a dashed line with an arrow. So once again, we're seeing some of the syntax. Now for data store, most information systems capture data for later use. A data store is a collection of data that is stored in some way. It includes the following: a number, a name or a noun, a description, one or more input flows, and one or more output flows. Continuing with data store, if the data flows are data in motion, we can think of data stores as data at rest. Data stores should describe things about which the business wants to store data. The data flow leaves the data store are data retrievals, and data flows entering the store are updates or new data added. And then for external entity, a person, organization, or system that is external to the system is what's captured with this. It has interaction with the system, and it includes a name and a description. So we can use the data flow diagrams to define business processes. Business processes are too complex to be shown in a single data flow diagram. A deliberate hierarchy is created with multiple levels of data flow diagrams, or DFDs. To build the hierarchy, we use decomposition. Child diagrams show a portion of the parent diagram in greater detail. And so this is just giving some example of a top level context, and then we have a level 0 diagram, and this is something that we're going to be seeing as we go over the next handful of charts here. So the process on a level 0 diagram each composed into separate level 1 diagrams. Process on level 1 diagram may or may not be decomposed into a separate level 2 diagram, so you can be thinking about how much detail is underneath that top level diagram. Processes are decomposed until each process has a single purpose primitive process. So here we can go from a level 1, we can go down to level 0 to level 1 to level 2, and these are the ways how that can start to be showing more detail. In terms of balancing, you want to ensure that the information presented at one level of a data flow diagram is accurately represented in the next level data flow diagram. Data flows on parent diagrams are carried down to child diagrams, and child diagrams adds new processes and new data flows. So first we have the top level context diagram. So this is the top level data flow diagram in every process model. It shows the context into which the business process fits. It shows the overall business process as just one process, or process quote 0. It shows all the external entities that receive information from or contribute to information to the system. Then we have the level 0 diagram. It shows all the major processes that comprise the overall system, the internal components of process 0. It shows how the major processes are interrelated by data flows. It shows external entities and the major processes with which they interact, and it adds the stored data via the data stores. Next, we have the level 1. It create one level diagram for every major process on level 0 diagrams. We show the internal processes that comprise a single process on a level 0 diagram. It shows how information moves to and from each of these processes. If a parent process is decomposed into, say, 3 child processes, then these three child processes wholly and completely make up the parent process. Then we have the level 2 diagrams. It shows all processes that comprise a single process on the level 1 diagram. It shows how information moves to and from each of these processes. The level 2 diagrams may not be needed for all level 1 processes. Correctly numbering each process helps the user understand when the process fits into the overall system. In terms of numbering, we want to have that laid out. So correctly numbering each process helps the user understand where the process fits into the overall hierarchy. So the context diagram is always process 0. A level 0 process are always numbered with integers. Level 1 processes always have a dot, and so 1.1, 1.2. Level 2 processes have 2 dots, and so 1.1.1, for example, and that would be the numbering scheme we'd be using there. In terms of alternate data flows, when a process can produce different data flows given different conditions, we show both data flows and use the process description to explain why they are alternatives. And a tip you want to remember is alternative data flows often accompany processes with if statements. In terms of process descriptions, text-based process descriptions provide more information about the process than the DFD alone. Case tools enable easy creation of descriptions, so that's something that we've talked a little bit about so far. If the logic underlying the process is quite complex, more details may be needed in the form of structured English, decision trees, and decision tables. Now let's think about creating data flow diagrams. And so building the context diagram, the top level data flow, you want to identify the external entities and the major inflows that supply and the outflows they receive. Want to identify all major processes encompassed by the context diagram, each major event and use cases, quote, handled by a process. We then create data flow diagram fragments for each event and use case. Each data flow diagram fragment is a mini diagram showing the process and the external entities in the data stored with which it interacts. So continuing on, we organize the data flow diagram fragments into level 0 diagram. We can decompose each level 0 process into level 1 diagrams, to compose level 1 diagrams into processes into level 2 diagrams as needed, and so forth. Then we validate each data flow diagram with users to ensure the completeness and correctness for that. Okay, we'll have some illustrations of developing the data flow diagrams, and so we'll show creating the context diagram, creating a data flow diagram fragment based on the use case, merging data flow diagram diagrams into a level 0 diagram, and developing level 1 diagrams for every process on the level 0 diagram. And so I'll just, for the most part, go through this a little bit quicker, but let me just go ahead and have a little bit of context for this diagram before we move on. And we've seen some discussion of a shop manager already, so you can have some familiarity with what we're listing. So data flow diagrams start with the information in the use case and the requirements definition. Although the use cases are created by the users and project team working together, the data flow diagrams typically are created by the project team and then reviewed by the users. The set of data flow diagrams that make up the process models simply integrates the individual use cases and adds in any processes in the requirement definitions not selected as use cases. The project team takes the use cases and rewrites them as data flow diagrams. However, because data flow diagrams have formal rules about symbols and syntax that use cases do not, the project team sometimes must revise some of the information in the use cases to make them conform to the data flow diagram rules. The most common types of changes are the names of the use cases that become processes and the inputs and outputs that become data flows. The second most common type of change is to combine several small inputs and outputs in the use cases into larger data flows in the data flow diagrams. For example, combining three separate inputs such as a customer name, customer address, and customer phone number into one data flow such as customer information. So here is an example of a data flow diagram fragment. So these fragments is one of the part of the data flow diagram that eventually will be combined into other data flow diagram fragments to form a new data flow diagram. In this step, each use case is converted into one data flow diagram fragment. You start by taking each use case and drawing a data flow diagram fragment using the information given on the top of the use case, the name, ID number, and major inputs and outputs. The information about the major steps that make up each use case is ignored at this point. It will be used in a later step. And so the figure I'm showing here is an example use case with a data flow diagram fragment that was created from it. Okay, and then we just have the merge fragment. So this is where we take the fragment diagrams and put them into a level 0 diagram. Here is a level 1 process 3 creating the parts request. So now we've had the use case put into a data flow diagram portion. This is process 4. They're recording the receipts of the components. And then finally, the process 5, they finalize the parts request. So then we want to be working on the validation of the data flow diagrams. And so here is some information. I won't read all of this. And so within the data flow diagrams, we want to be looking at the process, the data flow, the data store, and the external entity that may be there. And you can read through the rest of that to get some perspective on that. And then across the data flow diagrams, we want to be thinking about the context diagram, the viewpoint, the decomposition, and the balance. And we've talked about those things up to this point in this chapter. In terms of semantics, we want to verify that we're using the appropriate representation. We're doing consistent decomposition as we're getting into the lower levels of detail, and we're using consistent terminology. What are some of the common errors? Syntax errors, violating drawing rules. And so having a tool that enforces that you need to be using the proper format can be helpful in that regard. So every data flow must connect to a process, and every process must have at least one inflow and one outflow. In terms of semantic errors, these are the errors in the meaning of the diagram. Walk through the diagrams of the users. They're going to be able to help you. They'll spot things. Verify that the input shown are logically sufficient to produce the outputs. Check the consistency level of decomposition and check for consistency in use of terminology. All right, we'll have 3 slides here for a chapter review and think about what we've covered. We explain the purpose of a use case in the analysis phase, the second of 4 phases in the system development lifecycle. We explain why use cases are commonly used in the analysis phase. We discuss the various sections found in a use case form and the purpose and context of each section. So you can have use case forms, that's primarily what we've used here, but you also can have use case diagrams, and I would talk briefly about how that is used in the system modeling language, a different kind of way of capturing functional detail. Explain how use cases can help the system analyst create a more in-depth understanding of the system's functional requirements. We describe how use cases can contribute to the development of test plans for the new system. We discuss the 4 steps of the process used to create use cases. We define the meaning and purpose of the 4 basic symbols found on a data flow diagram. And then we've explained the meaning and purpose of a process model's context diagram, a process model's level 0 diagram, and a process model of a level 1 diagram. We did those one at a time. We explained the concept of the decomposition and why process models are created as a hierarchy of data flow diagrams. We described several common syntax and semantic errors found in data flow diagrams. We discussed the process used to create a process model. And finally, we discussed how the process model contributes to the development of the new information system. Okay, a lot of useful information, and we've also had a chance to have more key terms that we've introduced. And so you can just pause the video, or even better yet, go into the textbook and make sure that you follow along with each one of these terms. And that would be a great way for you to finish up the discussion on this chapter. All right, thank you very much.